Well, hello everybody. Good morning and good afternoon, depending on where you are. We have a number of people from North America online, as well as some people from Europe and Africa. So welcome everybody. Today we have a great webinar lined up for you. It's called Improving Road Safety Using Data Visualization and Analytics. My name is Barry Raskin. I lead the marketing team here at AgileAssets and will serve as your host today. My first question for you all is, can you hear us? If you have a problem with audio, please type into the Q&A and let me know. But hopefully everyone has no one has a problem with the Q&A, with the audio. All right. Some more housekeeping items. We very much value your time today, so this presentation will stay on schedule. It'll last about 45 minutes for presentation and demo, leaving about 15 minutes at the end for questions. All dial-in participants are muted. We have a number of people on this webinar. We want to limit the background noise and distractions. If you have questions, enter them into the Q&A window on the right side, and we will address them at the end of the presentation as time permits. If you don't see the Q&A window, put your cursor at the bottom of the window and look for the middle button, and that will give you the Q&A window. This webinar is being recorded. We'll send the link to the recording and the slides next week. At the end of the webinar, you will be offered a very short survey. Please take a moment to fill it in so that we know we can learn how to improve these webinars going forward. We have a great presentation for you today as we discuss and show you how you can improve roadway safety in your organization through the use of safety management and visualization tools. Using the advanced analytics of AgileAssets safety analysts, those responsible for roadway safety gain a systematic way to identify crash locations, evaluate countermeasures, and assess economic impacts. That's with our AgileAssets safety analyst. With the addition of AgileAssets Summit, decision makers can drill down to see crash patterns and distributions using advanced data visualization techniques. And finally, we will discuss a case study that shows the results of distracted driving using crash analysis through these tools. Our presenter today is Dr. Shaful Azam, Senior Product Owner and Consultant at AgileAssets. Shaful has over 7 years of professional experience here at AgileAssets, plus 4 years of doctoral work in transportation asset management. Shaful is a subject matter expert of safety management systems and is product owner here at AgileAssets, guiding the enhancements and best practice usage of the AgileAssets Safety Analyst module. His experience includes functional lead roles in West Virginia's Safety Management System, Montana DOT's award-winning Safety Management System, Georgia Maintenance and Signal Management System, as well as functional lead and technical expert for the Georgia Bridge Inspection and Analyst System. Some of you may already be familiar with Shaful, as he has been a regular speaker at TRB and Astro conferences. Please welcome Shaful Azam.
Thank you, Barry. I will share my screen, and Barry, let me know if you can see my screen. Not sure.
Yes, it's coming up. There it is. You're giving us the headline.
Yeah, let me go to the first slide. And you should see my first introduction slide, right?
Yes.
So good morning and good afternoon. Welcome you to this presentation. Today I'm going to present an overview of safety analytics analytics and visualization component in AgileAssets Safety Analyst module, and also the visualization tool that we have, which is the Summit tool. And my purpose of this presentation will be to show you how we can use this tool to make better and precise decisions to improve the safety, roadway safety. So here's a quick outline of today's presentation. I will start off my presentation with a brief discussion of the safety aspect in data analytics and visualization. Especially, I would like to give you some highlight why this is so important. Then I will give you an overview of the data analytics framework in Safety Analyst. Then I will also cover the visualization framework in Summit. Then I will introduce you with a safety engineering persona. Persona, I mean, many of you may not be aware of that specific terminology. Persona is a fictitious character that we use in the product management to identify the roles of the standard user, and it actually helps us to identify the features and functionalities that we need for the software. So we'll cover that first persona. Then I will have a presentation on a case study on the distracted driving. Distracted driving is one of the recent crash trend, and we are seeing in different states in US and also internationally, this has become a big challenge for the transportation agency. So I'll go over a case study with that. Finally, we'll have a question and answer session. Now let's start with a general understanding of data analytics and visualization for safety improvement. The first thing is we have a big network to analyze. And how big? Go back to the first slide. So how big is the network? The network is almost like 4.1 million miles in US, and there is roughly every year there is almost 5 million crashes per year, and this is total 35,000 to 40,000 deaths on the roadway. So therefore, we are dealing with a large data set to analyze, and we need to have use the best of the analytics to identify the issues so that we can fix the problem and save lives. So big challenge is having a big network. We also need to deal with many diverse variables, and that means we have these MMUCC elements, which is model minimum uniform crash criteria. So any crash that has this happening in US, you are roughly estimating 150 elements for that in the police record. These elements, along with the interaction of this element, need to be analyzed to identify the risk factors so that you can come up with the best solution that can resolve the issue. So definitely these diverse variables is one of the reasons why we need to have a better analytics to identify the root cause of the issues. We also need to make a precise investment decision. And for example, transportation agencies, we all know about different Federal Transportation Act. For example, we have the MAP 21 and the FAST Act. And these acts are allocating certain funding for the transportation agencies. For example, the current Federal Act, which is the FAST Act, it authorizes roughly $305 billion for the fiscal year from 2016 up to 2020. And this paragraph actually shows you the funding that is allocated for the highway safety improvement program. But in order to get those funding, the agencies need to come up with a better plan and need to identify the locations and to justify the funding. And the analytics and visualization tool can really help in pinpointing the root cause of the issues and the location that you need to make those investments. We also need to be proactive rather than reactive, because the proactive safety management plan is something that we consider to identify the locations on the network that need some safety improvement. For example, if there are roadways you are not making good investment of that, in the long run, the roadway will deteriorate and can be hazardous to the traffic. So the proactive measure will help in the long run reduce any costly rehabilitation costs as well as any hazardous safety aspect. And in order to run a proactive screening, it needs a cross-functional integration of safety management tool and other asset management. So the idea is to build a robust data set that we can analyze to identify any proactive measures that we need to consider. We also need to, we have a goal to reduce the data clutter. And what does mean that in safety analyst, when you start with any predictive model, we start with a fairly large amount of variables. But we can actually narrow down to the minimal variables that we need to focus on. So for that, we need to have a better analytics tool. We generally use the confidence interval to narrow down our investigation. So in the final safety performance function or any other prediction model, we deal with a handful of variables that we can control and can use the best strategy to reduce the number of accidents. We also need to learn from the past. What do you mean that when we are implementing any countermeasures to mitigate the challenges, we have to look back and see whether the countermeasures were effective or not. All of you are familiarized with the regression to mean effect, right? There is a natural tendency that if we do not consider the exposure and the temporal variations of the performance indicator, then we might lead to a totally different conclusion. That's why we need to have a good understanding of the analytics and also to apply those for the safety project evaluation. For that, we have different techniques like a before and after study and also the train analysis and the temporal and panel data analysis that can help us identify those temporal patterns. Now, I'd like to give you a quick overview of the safety analytics that we have in our safety analyst tool. The first thing we have is the predictive analytics. The predictive analytics is used to find out the causal relationship of response variables to any other interaction variables and the predictor variables. And if you think about this predictive analytics, we actually have a frequency model, we have severity model, decision tree, and machine learning techniques. The frequency model that we have is it actually can be a fixed parameter model or it can be a random parameter model. What we mean by the fixed and random parameter is if it is fixed parameter, then the effect of a variable is actually fixed in the geographic regions. It's not changing. So if you develop a model in Texas, for example, if it is a fixed effect model, then the same model will be applicable to any other states, like say in Minnesota. If you have a random parameter model, then the variables have a different sets of parameters, and it actually varies by regions. So it considers those regional aspects and any other unobserved heterogeneity that we call in statistical terms that can be captured in the random parameter model. We also have the severity models, which is for any crash that is happening. We have the CAPCO scale, like fatal and 3 types of injury, ABC, and we have only the property damage only crash. So this kind of severity, and we also have the if the person is admitted to the hospital, then we can also have the maximum abbreviated injury scale, MAI scale. So each of these indicators can also be predicted by using the severity model. And we generally use the logistic regression model for the severity analysis. We also have the decision tree and machine learning techniques. So when you are running the proactive screening, we generally use the help of decision tree to identify any patterns that we need to consider. Or if you have a safety program that you can actually predefine the decision tree to make it better decisions. And the machine learning is something that is being recently used to actually use the model using the test data and make sure the model can predict in future for newer aspects. So the model itself learns from the data feed and can deal with different situations. So that's something we are increasingly using, and it will be a decent general trend for us to go in that direction. This is a generic framework we have in our safety analysis, how this predictive analytic works, we actually maintain a crash filter in our network screening. We also manage the safety performance function, which is the 6-parameter model. Then we run the network screening. When you are running the network screening, we are basically considering the SPF, and we are computing the empirical base adjusted crash count. Finally, we're getting the level of service of safety, and that can be used to identify the hotspot. And then we follow through other safety management steps in this framework. So if you already identify the hotspot, then the next step will be to come up with the countermeasures, do diagnosis countermeasures, and finally project selection. Now let's talk about the exploratory analysis. So in our safety management system, and we have this rich set of data sets. So we have this crash record that we are capturing every year, and this crash record can be used for any exploratory analysis. For the exploratory analytics, we generally depend on the expert judgment, so we can actually build different complex filters to narrow down our search. Just to give an example, if you are looking for the driver's distraction, you can actually start with the crash data. You can consider whether this is a rollover crash or a fixed object crash, and then you can, if it's a rollover crash, then you can consider the grade of your terrain, whether it's a level terrain, rolling or mountainous. When you're considering the level terrain, then you can look at the different behavioral factors, whether the driver was using cell phone or not distracted. So if you are looking at a specific safety problem, you can actually consider all these aspects and can actually build a complex model to find out, to explore the data sets. Finally, we have the spatial analytics. This is an example of exploratory analysis, which is, we'll go over this one in our demo, that we have this Summit tool that can actually help us identify different aspects of the exploratory analysis, and we'll cover that in our demo. Just quick overview of the spatial analytics. This is an example like the distracted driving heat map that we generated by using the SD tool. So the heat map shows like the cities that have a lot of the distracted driving. So if you are planning for a cell phone banning zone, then this the perimeter of that circle can actually help us identify those boundaries. So sometimes this spatial analysis can be really helpful to make a better decision in your for your strategy that you're going to take. Now let's take a quick overview of the analytics and visualization framework that we have. So we start with this data, safety data and infrastructure data. So these are part of our safety analysis and this solution. Combining these two, and with the help of network screening and diagnostic engines, we run different scenario, and that gives us the screening results, which is the network screening results. And these network screening results can be an input to the visualization tool. And we'll cover those visualization tool that we have Summit visualization tool that we can feed that information there and can run, can actually visualize the data from screening results. The next step of the screening is running a cost benefit analysis. So we consider the treatment library that we have. We run the cost and benefit analysis to identify whether the safety projects or countermeasures that we are considering, whether those are economically viable or not. And from that, we get a list of projects. And that list of projects, which is the initial stage, the planned project, that can also be fed into the visualization tool to do some analysis. From the cost benefit analysis, we go to the next pages. We have two different pages, and there can be more pages within that boundary. We have the project recommendation phase, and we have the project completion phase. Any phase that is recommended by the safety engineers, that become part of one bucket. So these recommended projects can also be analyzed. And finally, when you complete the projects and we have the benefit, the actual benefit of the project outcome, we can definitely consider that in our visualization as well. So in a nutshell, what I'm trying to say that we have this safety analyst, which is a tool that can do all this analytics, and it run different engines and different analysis to give you a very rich data set. And finally, the visualization tool can be used to visualize those information. Now, I would like to introduce you with a safety engineer persona. We discussed before that the safety engineering, the concept of persona is to identify a user or a role that can help us identify the software need or what kind of product features and functionality we need to incorporate. So by looking at the day-to-day activities of the persona, we can identify that. So the persona that we use in safety analyst is Alicia. She is a safety engineer, and her day-to-day activities are to oversee the overall safety program for the agency. She actually collaborates with other safety management programs within the agency, and she spends time in significant time in reviewing the outcomes of network streaming and validating the crash definition. So when you look at the persona, we also identify the goals and the solutions this role is seeking for. So the goal of this persona is to ensure that the agency is moving towards the Vision Zero target, and also ensure that the appropriate safety programs and projects are nominated each year. And when you consider the program and project, we consider that 4E. So the engineering, treatment, the education, enforcement, and the emergency response. So these 4Es are considered as the safety projects and programs. So one of the goals of this persona is to ensure that we have the appropriate safety programs embedded in our solution. Finally, she needs to make sure that she gets the maximum return on the investment through the efficient benefit cost analysis. The solution that we would like to provide is setting up, execution, and comparing multiple scenarios, review the recommended projects, and after going through the nomination cycle, and finally is in generating the reports. So when you are generating the reports, making sure that the reports are very robust and can be drilled down by different personnel in the agency so that they can make better decisions from those reports. And I mentioned that the use of this persona is to guide us to come up with a better software solution. Finally, I'd like to talk about the visualization framework before I'm going to the demo. So we have the visualization technique. We discussed that we have 3 different tools that we use. The AgileAssets Summit, that is we use to reach the dashboard for the safety engineers to look at different trends in the data sets. We have the ArcGIS Online, which is we have this our safety analyst tool can be integrated with the SD tool, and ArcGIS Online can be used for generating those special graph or the special statistic that I showed you, like for example the heat map or any other special analytics that you want to run. We have to use the ArcGIS Online tool for that. Finally, we also have a Jasper server for any ad hoc reporting or any other complex CAN report that the safety engineers would like to make. With that, I would like to go to the demo and to show you a case study on the distracted driving, how the solution actually works. So the first thing is in our safety analyst tool. Right now, the tool I'm actually showing is for Montana Safety. When you log into the screen, you will see that we have this HSM methodology. Actually, this software is based on the HSM, which is Highway Safety Manual methodology. So you see that we have the database management system in one menu. We have the network screening, diagnosis, countermeasures, analysis, and reports. So when you are running, for this specific case, when you are running a analysis for the distracted driving, we need to make sure that we create a specific crash filter for the distracted driving. And what does this crash filter stand for? These crash filters can actually help us narrow down a specific type of the crash. So you see that in our software, in network screening, we have a window where we can actually set those custom crash filters. In this specific case, I'm using a distracted driving, whether the driver was distracted or not. This is the filter I'm using. And if you look at that, it is giving me an option to choose what is the variable that we are considering. So we have a variable in our crash database called distracted, whether driver was distracted or not. The answer is yes, we are considering that in the filter. So now when we have this filter available, then we can actually use this filter to run network screening. The network screening tool is available under in safety module and under network screening. So it's actually it is a big window. It has a lot of functionalities. I'll go over one by one. The first thing we have is the network screening scenario pane. This pane actually you will start with creating a new scenario and you can put a scenario name. In this case, you can say, okay, I would like to go for an HSIC funding. So, and my plan is to come up with a plan for the distracted driving and what is the program we're going to consider. We can consider those scenario. You can identify what safety profiles you are using. So profiles is more like your scope of the network that you are considering. Suppose you are planning for only for your district and running a scenario for that, then you only pick up a profile of roadway network that falls within your district. Now, if you're running a scenario statewide, then you generally consider a statewide safety profile. So you can consider like, okay, in this case, I'm running a profile that is statewide for all route, and the route is divided into 0.1 mile window and 0.1 mile step, which is, if you know, in highway safety manual, we have a sliding window technique that you can use to dissect the route into smaller segments, and within one segment you can actually run a moving window to identify, to scan the network pretty much, and to identify if there is an issue with that or not. So the safety profile is basically you identify the profile that you are considering. Then you have the selection of other parameters like what crash filter you are using. So distracted driving or roadway departures, you use those filters. You specify your crash date, which is date from and to, what is your analysis period. And you also have some techniques like what will be your hotspot selection criteria. So you can consider, okay, my hotspot will be like say top 95th percentile or top 90th percentile. So that hotspot selection criteria you need to provide in the hotspot rule. Now the next thing that I would like to highlight is this part, which is the scenario profile. So we have actually two different profiles we have. When you're running a screening, as I mentioned that we have the safety profiles. So the safety profiles consider that that each of the route are considered as a main profile, and within that route, the subsections are considered the secondary profile. So we have actually two different window here. The top one is actually pulls data from the list of the route, and the bottom pane actually pulls the record of the segment within that route. Finally, when you run this analysis, which is you actually identify hotspots, and there are actually about 2 or 3 different steps before that. You can load your profile that actually generates those results. Then you edit your scope, which is if you want to narrow down your profile, like for example, the roadway locations that you have, you can actually run an analysis for a specific road. So you can do a further filter on that by edit scope. And then you calculate your level of service of safety, and finally you identify your hotspot. So this workflow you need to consider to actually eventually identify the hotspot, and that hotspot will be in a different tab in the same screen. So the idea of safety analyst, as I mentioned, is actually to generate those rich data sets that can be further analyzed using a Summit tool, which is our visualization tool. So in safety analyst, we also have a diagnosis engine. So we consider that we can actually, all the hotspots that you are identifying, these hotspots, for example, are embedded here. And we are putting a additional layer to that. This case, we are putting the fatal injury, and we can have, okay, the injury, we just need to identify the fatal crashes that are happening on that specific hotspot. We can also bring in like additional information like the traffic volume, maybe a different layer to that. So we can actually correlate if there is any relationship with the traffic volume and the number of crashes we have there or not. and any other additional layers that are available. So you can have, if you have a guardrail data or you have a shoulder or median information that if you need to consider in your diagnosis, you can also bring in this GIS platform. And from that, you can actually try to identify factors related to that. So this is one of the way you can run some of these spatial analytics in our solution. So that's pretty much what we have in safety analyst solution, that we can run those analytics. Now I would like to cover the little overview of the Summit tool. A Summit is a visualization and business analytics tool. It's actually applicable for large infrastructure asset management database. Suppose you have a safety database and you have combined the database with the infrastructure data, and you want to bring in that rich data set into the Summit platform. The Summit platform, the way it works, it can run, analyze the data for any variable. So all the factors that we have, like I mentioned, that we have roughly 115 different variables that are part of the crash data set. If you bring in all the variables, each of the variables can be analyzed using the Summit platform. However, one thing I would like to mention, that the role of the Summit platform is actually mainly for interactive analysis, reporting, and sharing the complexities with the other asset management systems. So initially, you will start off your analysis using Safety Analyst tool to get a better understanding and identify the hotspot, and then you actually push those data sets or the results into the Summit data for further exploration. One more thing, that how the Summit can help. This is an example that in safety division head, we have different entities like the safety program managers, safety engineers, and we also have the governor's highway safety program. So they can be the user of the Summit. So the idea is they have an access to the data sets to look at the analytics and the report capabilities to come up with some kind of solutions. We can also the other divisions that are not part of the safety division, like any legislative representative that we have from federal highways or any other representative, city and county, they also have issues, and also highway safety patrol officers. They can also look at the Summit dashboard to get a better understanding of what's happening. And in the demo I was showing, the Summit is actually a distracted driving condition. So definitely highway patrol officers, they have a lot of interest in looking at this kind of results. So let's do a quick overview of this Summit, how it works. So I would use this environment that we have. I created a dashboard using Summit. This is actually a distracted driving dashboard. Let me give you a quick overview of what this dashboard have. So in this dashboard, we have, the first thing we have is the collision type. So for any distracted driving, identifying the collision type is really important. So if drivers are distracted, what are the different types of collision they are having? So we can look at those collision type, and we can see that in this specific case, make it a little bigger. We have those single vehicle crash. Those are type of the crash at the highest numbers of crash related to distracted driving. Then you have the front to rear crash, and then we have the side swipe same reaction crash. So if you look at those, like for example, the front to rear, which is more like a rear end crash. So if you are working in a signal and you got really distracted by your cell phone, there is a possibility that you just lose the control on the brake and can hit a car in front of you. So that's something that can happen when you are really distracted. When you are driving and you lose control because of any other distraction, it can be cell phone, can be any other aspect, external or internal stimuli, that can cause this single vehicle crash, which actually is really fatal in nature. Let's go back to that. Just give me a second. I think I accidentally closed the Summit dashboard. Just bear with me a second. Okay.
While Shafula is getting the Summit demo back up, if you have any questions already, go ahead and start filling them in the Q&A panel on the right-hand side. Thanks.
So, sorry about the interruption. So, collision types, we discussed that we have these different collision types. The second, the visualization that we have here in this dashboard is showing you a seasonal trend. So, for example, that I'm interested to see in different time of the year how the distracted driving trends are changing. So, if you look at that, and you can actually maximize the screen. Generally, there are some peaks of distracted driving in June, July, August, that time frame. So if there is in summer time frame, there are a lot of drivers on the road, and especially this is a Montana condition. So generally, Montana we have a very cold winter, so we don't have that many drivers on the road in the. I mean, even though there are drivers on the road in the winter time, they're really cautious when they're driving. So we don't have that many crashes, distracted driving crashes in the winter time. However, in the summer time, there are a lot of distracted driving. In this one, you can also slide in the windows and can look at different years, and we can actually adjust the boundary that you're looking at. Suppose in this case, I have the crash from monthly crash distribution from 2018 all the way to 2013. You can actually, on the right-hand side, you can see crash date that you should be able to adjust, or the time that you're looking at. You can have a different time frame that you can set. So this is actually your control that how you can expand the time frame. As long as the data sets are part of your solution, that graph will show you, display those results. The next thing I'd like to discuss is that rural and urban trend. Suppose I am interested to see all the single vehicle crashes that are happening. How many are happening on the rural road and how many on the urban road, and what are the trends in recent years? If you select single vehicle crash, if you look at this rural and urban trend, it shows you that in generally there are a lot of rural crashes in Montana, and there are not many crashes, urban crashes on the Montana if you consider the single vehicle crash. But if you consider some other type of crash, you might have a different picture. For example, I just took off this filter, and it shows me that in general, if you don't narrow it down with the single vehicle crash, there is a tendency that the urban crashes are increasing, especially in recent years, and the gap between rural and urban crashes are gradually reducing. So people on the urban area are getting more and more distracted in the recent days. It gives you that kind of trend. Now let's take a look into the distracted driving by cities, and actually it can give you some idea when you are concentrating on we're trying to find out a solution for a specific city. Like you can consider, okay, I am interested to find out a solution for Bozeman, which is a city in Montana. So what you can do, you can just look at, first of all, let's look at all the cities, the distraction that we have, and it shows you list of the cities, and you can see the high peaks that Bozeman is really having a lot of crashes. And these crashes are by different types. So you can see there the group of crash, like the first one is actually distracted by other inside the vehicle. If you look at the second slide to the second one, it is the other inside the vehicle. Then it is the electronic or cell phone use. So we have different types of crash distraction type that we can browse in this. So let's actually consider one specific city, so we can show you a quick demo for that. So in my distraction by cities, I will just choose Bozeman, and what it shows you that for the Bozeman city, you can actually, I have other inside the vehicle. That was the crash criteria, so I can actually get rid of that. I can only choose a Bozeman city from the filter that you have on the right hand side. So you can see in this right hand side, I have a global filter, because I don't want to consider a specific case that I only one type of distraction. So I can use a global filter, say Bozeman, and it shows you that okay, this is what is happening in Bozeman in terms of crash trend. So look at this one, for example, there is a increasing trend in recent years in Bozeman. So 2009, 2010, and then when the smartphone and all things came, there's a slight jump to the crashes. So that is kind of concerning. So we can look at the recent trend and can come up with a better strategy like enforcement or education or campaigning that we need to consider. Suppose I want to focus on only the electronic distraction, which is distracted by navigation device or cell phone. So we have a driver distraction mode. You can only consider the electronic distraction. Now it shows that it definitely have a pattern. It is actually quite fluctuating. It is even in November, sometimes in September, those are some of the high peaks we have for one of the city. If you look at the overall city, I can actually get rid of the filter and look at all the aspects of that. In overall in Montana, what is happening, the cell phone usage. Now let's look at one more behavioral factor, which is the male and female driving trend. So there's already a debate who is a better driver, male or female, but we can look at some of the crash statistics. Who is actually getting more distracted on the road? So I choose the cell phone communication, which is the type of the distraction we have. Now let's look at the trend we have in Montana for male and female. We can take a look that there is definitely male drivers are more distracted, so a lot more crashes than female drivers. There's an increasing trend of the female drivers from 2009 to 2013, and this is really flattening from that time frame. So looks like some of the reason why there is a flattening in recent year is probably the some of the campaigning programs that Montana DOD are considering. So it is helping flatten some of the recent trends. But definitely it's not increasing, but needs more strategy to bring it down, the crash trend for any drivers, irrespective of male or female. Okay. The other thing we can also do in this, we can also consider some of the geometric aspect of that. So I consider the roadway shoulder width. I'm trying to identify if I'm getting distracted by cell phone, whether having a better shoulder width will help me reduce the crash or not. So it's giving you a quick summary that if a shoulder width is really low, I mean in this case, if you look at this, the blue one is 6 feet shoulder almost. Right? The green, the dark blue is actually a 2 feet shoulder, which is very narrow, and the orange is the 8 feet shoulder. So you can see that this doesn't have any bearing. Like where if you are getting distracted by cell phone, it doesn't help. Like if you are a narrow shoulder or a wide shoulder, yeah, if you lose the control, it's really hard to avoid crash. So this is a kind of a pattern that sometimes the engineering treatment will not work if you are really distracted by a cell phone or some other device. If you take off the cell phone, let's look at the overall distraction pattern, and we can have the same conclusion that although there are a lot of crashes on the zero shoulder, but there is also a high number of crashes when you have almost 8 feet of shoulder. So it actually doesn't help if you're really distracted. So in quick summary, that I would like to consider that safety, and definitely the safety, the demo that I provide, one of the aspect of that was to show you that how the safety, how the dashboard help you to identify different crash patterns. And this is a tool that not only the safety divisions can use. There is also like a group of people like the legislatives and the city, county, highway patrol. They have the different interests in using this kind of tool, and it can really help identify the crash pattern, identify the locations and the cities or the crash trend, so that it can help identify those 4 E's that we discussed in our earlier slide. That we have these engineering treatments, the enforcement, education, and the emergency response. These are the 4 E's that we want to make sure that that become part of your safety management. And definitely having a better analytics and a better visualization help you leading to that direction, and you can make the best decision that within your budgetary constraint, and can really help improve your safety conditions on the roadway. So with that, I would like to conclude my session. I look forward for having questions from you. Thank you.
All right, everybody. Thank you, Shaful. This is a good time for you to add some questions into the Q&A, please. And here are a couple of questions. Shaful, do you have a recommendation for the data we would need to use this methodology?
Yes, so as I discussed in one of my slides, I actually go back to this just to give you some idea that when you're using safety analyst solution, there are different data set that is being generated from the solution itself. So if you want to consider what you need, I would tell that you need safety data and definitely the infrastructure data. These are the two things you should have. So infrastructure means a MIRE data set, model minimum roadway inventory that you need to collect for your agency. That is something we definitely need. Your crash record, if it is MMECC compliance, that actually really helps. So having that two compliance, and then the remaining part of that, how these two things will be merged into bringing a rich data set. Those are something our safety analyst tool actually can perform. That's why I'm bringing that slide, that when you run the analysis, it's actually generating a rich screening results that can be directly linked to the visualization tool and can feed to the engine to display all these visualization. So generally speaking, you need crash data and the roadway inventory data to run this analysis. It will be best if you have the crashes geocoded, which is you have the locations like route, mile post. Those information will help running this analysis.
Shaful, what I suggest is open up your Q&A panel, because I think some of the questions are going straight to you. But I'm going to continue on some of the ones that are coming to me. How do I start collecting data, and in what format should I be collecting this data for using in these tools?
Okay, so if you want to collect data, I would suggest that for MIRE elements, I think I can talk about the safety data and infrastructure data. These are two different things. Safety data, which is mainly the crash data, is generally collected by the safety by the law enforcement agencies. So in our system, when you implement safety analyst, we generally bring an interface with this with the external crash reporting system. It can be SmartCop, can be other system that we have. So it generally loads the data from that crash reporting system to our solution. This is how we build the interface. For the infrastructure data, if you do not have the data, if you want to collect, first of all, you might have data within your GIS division, then generally have the roadway data. If you do not have data and you want to collect the MIRE elements, we actually help like building that field tool that you can use. We have this the mobile device, like we can integrate with the collector, AG collector, or can have our in-house other mobile solution that you can use in the field to collect the information. So it's generally speaking like we need to know what stage you have your data. It might have, if it's part of your GIS team, you can definitely collect from there. If you want to collect, then it has to be some kind of solution that we can provide for data collection.
Okay. Do you have any questions on your panel, Q&A panel, Shaful, or should I keep going?
No, I don't see any.
Okay. How do you determine which safety project or countermeasure to program and prioritize over other potential products?
Okay, so that's a very good question. So when we, first of all, we have these project recommendations. So what we do is, generally speaking, we run a benefit and cost analysis that actually bring in records from the treatment library. And you can actually do in two different ways. We can actually build decision tree, so that can suggest to you, okay, given that condition, these are the 5 or 6 treatment that you need to consider, and that decision tree will be a rule-based decision tree that safety engineers can predefine. So when you are composing the project, those projects will be considered. This is one way to do that. The other way is more like an expert judgment. So when you run the benefit and cost for multiple scenarios, suppose you have like alternate 1, 2, 3, you can look at each of your benefit and cost, and maybe most of the time the lowest cost and highest benefit and cost ratio that are considered as a project for your the safety countermeasures. So all of, I think many of you knew about crash reduction. We have a clearinghouse for that, crash modification factor. That clearinghouse actually have the information of different treatment that you can consider for your safety mitigation, and it also have a list of the crash modification factor or crash reduction factors that you can consider when you are coming up with the countermeasures. So generally speaking, if you have the highest crash reduction factor, that you generally consider for your safety program. One more thing I want to say, if that is a decision between your engineering treatment versus education enforcement, it actually depends on your particular use case. Like if you are doing a distracted driving solution, then you need to consider more like the enforcement or education program rather than your engineering aspect. If you are considering, say, the run-of-the-road crash in mountainous regions, it is more related to your terrain and engineering aspect. You might need to consider if there is any guardrail or not, whether there is adequate shoulder width or not, whether there is a safety edging or not. So those engineering factors you need to consider. So it depends on what scenario or what particular problem you want to solve, and from there you can run benefit and cost, and there is a competing project. The tool can tell you what project you need to consider.
There's a follow-up question, Shaful. How does the system allow us to determine the effect, the results of an implemented countermeasure?
Well, that's a very good question. So in our project completion window, we have a before and after tool. So the before and after tool is generally speaking that when you are done with the project, you specify your before window, the time frame. So you can say, okay, I did my project in 2015. I would consider my before scenario 2011 to 2014, and say my after scenario will be 2016 to 18. So you just define the frame for your before and after scenario. And then we have, since our safety data is already part of the system, it actually update your the performance metrics for before and after. It pulls the record from crash data, and it computes the before and after crashes. It should not only compute the crash number, it also computes the overall economic loss, which is considered the injuries in crashes and what is the economic loss for that. Eventually, what you get, you can compare your before benefit and cost scenario with your after implementation before and after scenario. And that gives you a very good retrospective whether your implemented project was a good choice or need to consider rethinking about something different in the future.
Okay. There's a question that I had. If I wanted to license these tools, how do I do that? How are they deployed? On-premise, SaaS, hosted? What options do I have there?
Okay, so we have both solutions. We can do on-premise or hosted. I think definitely the SaaS solution, the hosted, which is our more preference. So that gives you your data will management and the maintenance will be on our part, and the deployment, because we generally do deployment in like every 6 weeks we have a new release come. So if you is in a SaaS solution, any new features for the product, that will be easily available to you, and it will be seamless. So just like your iOS the software that you have. Whenever there is a new version comes, you don't notice that. You just need to install something, it goes like that. So SaaS solution, I think, would be more preference, but we have both, like in-house or SaaS implementation. Generally speaking, when we implement the project, we run the initial stage of the project. We have those discovery sessions. We look at your data sets, look at your the current infrastructure you have, and identify how many interfaces we need to make, and what will be the data flow, and look at all the use cases, identify any persona and what are the needs for that. Those kind of product features identification talk we do in the really early stage. But we generally try to align with the standard solutions. We already have a core solution, the Safety Analyst and the Summit. That's something we consider as our standard solution, and we tweak as we go if we have something different, some custom we need to make or not.
Final question, as we're running out of time. If I wanted to bring on safety management into my agency, are both tools that you described today required for a safety analysis and safety management system, or when do I need one or the other?
That's a very good question. The answer is, generally speaking, these two tools are independent. So, but I would suggest that if you really want to run, like for example, the framework I showed, that your engine is running in Safety Analyst. So your data sets and all these rich data sets, the interaction with the infrastructure data, those are all coming from Safety Analyst. So Safety Analyst is kind of the major component that we would like to implement to give you, to provide you the rich data set. But if you already have those rich data sets already available, then maybe that can be visualized in Summit. Summit is more like a tool that is independent of the solution, but it just connected with that overall ecosystem of AgileAssets. So you can pull data from not only from safety modules, and from other modules, and we can build a cross-functional dashboard to show you a different direction. But these two things are actually, if we consider overall solution, I would say these two goes together, because you need someone to run the analysis and give you the rich data sets, and you also need some users that would only look at the results and can make decisions from there. So from that perspective, and as an overall solution, these are actually kind of complementary.
All right. Shaful, thank you very much, and thank you to everybody online for joining us today. Please take a minute to fill out the webinar survey as you exit the webinar. It does help us, and it will only take you a minute to fill it out. We look forward to having you participate in one of our upcoming AgileAssets webinars. Thanks again. Have a good afternoon.